Okay, howdy and welcome back. So reading from standard N and from files. This is, I don't want to say it's more tricky, uh, but the kind of conceptually what's going on behind the scenes is a little bit, so before we were focused on, okay, we'll probably have to write to some sort of format. When we're reading in, we're going to have to know the format of that which we're looking to read in. So reading from standard output. To do this, pound include IOStream. And remember that any sort of input provided through standard input will be through the terminal window in VS Code when you get it open. And this is going to be formatted reads, and the contents are going to be read into objects. So let's say I'm expecting two strings as input from the user. Again, not worrying about error checking right now, but that is definitely something you would like to consider when this goes live. So we have the two, we have to declare the objects that we'd like to read into up front. So we go ahead and introduce, okay, first name is going to be a string, last name is going to be a string too. Then it's always probably good practice. Let's go ahead, prompt the user and let them know what we're looking for them to enter. And in most cases, a better description than what I have here is probably warranted. Enter your name, maybe enter your full name, first name, last name, separated by space, whatever your expectations are. Be sure to tell them that's how you're expecting them to provide you with the information that's requested. After there, we simply begin reading from CN, which is bound to standard input. Notice here my angled brackets are essentially, again, pointing in the direction of information flow. So information is coming out of the standard input stream, and it's going into first name followed by last name. So at this point, you might go, well, how does it know to put the first name in first name and the last name in last name? Well, reading using standard in is going to be white space delimited. So when we're dealing with input streams or streams in general, think about dealing with individual characters kind of flowing in one direction or the other to standard output or in through standard input. So as the characters are coming in, CN recognizes essentially that, okay, first place where we're storing this is a string. So I'm going to essentially be allowed to put any sort of character data within that string. So it'll start reading, it'll get M, it'll get I, it'll get C, H, A, E, L. Then it will read a white space. Because the CN is going to read using white space delineation, at this point it knows, okay, I filled up first name, and now the next portion of the input is going to begin going into the next string, in this case, last name. So it continues on, N-O-W-A-K. And again, a line feed would be considered a white space. So it would have, at the end of this, successfully read it Michael based on what the user or whatever the user typed. And then whatever came after the space would be read into last name. So at this point, you're probably going, that's cool, but what if I want to say, get a whole line of data? So I don't want this white space delineated input. Well, in that case, if you're interested in reading a whole line of text into a single string object, the composition of this is going to be a little bit different. Of course, you're not going to need to declare a string for which you're going to read that information into. That's done on this line right here. Full name is going to be a string, and that's where our data is going to go. Likewise, since we're getting input from the user, I'm going to go ahead and prompt them to enter their name. This is no different than what we did before. However, opposed to using CN, which is white space delimited, to read in the contents from this stream, we're going to use the standard library's getLine function. The first argument to this function is going to be the stream to get the line from. The next is going to be where we put that line. So where the line goes. And then exactly as what happened before, the input begins to being processed. So we keep going, M-I-C-H-A-E-L, still on the same line. So we're still going. We'll pull that white space and actually put it into the string that we're forming, N-O-W-A-K. Okay, and oh, hey, I'm at a line feed. So now at this point, I know to stop. So this whole sequence of characters is put into full name. So full name gets Michael Nowak, and that white space is included. Let's kind of continue on this process and really emphasize what it means to be using formatted reads, especially when we're interacting with CN. So what if I wanted to read an integer followed by a double followed by a string? So this is going to be a formatted read. So my input is going to be something like 10, 3.14, and then some text. Well, the input that I'm looking to read this into has to match the type of the object that I'm reading it into. So in this case, because I'm looking for int double string, I'll declare those variables up front because that's where the information's going. And then I will essentially read from CN into I, and I is going to expect a integer. You will have issues if you attempt to read, say, something like a character. Then we're going to read a double, and then we're going to read a string. Now, notice here we're going to heavily rely on the white space, and I'll kind of show what happens if this wasn't white space delimited, what that means for formatted reads using CN. So we're going through, we begin processing, okay, 1, 0. Both of those characters can be stored in a digit as the decimal value of 10. Okay, cool. So we've got 10, put it into I. Here's our white space. So we skip over that and we begin processing a double. 3, that's a valid character for a double. Period, that is a valid character for a double because of the decimal point in it. Okay, 1, 4. Those are all valid characters for a decimal, and we know that we've read the entire number when we hit that white space. So 3.14 gets thrown into D. Now we're expecting a string. So we begin this process again. We put the arrows there so it looks consistent. So T, that's going to be put into str, E, X, T. And then we've hit a white space. So text will be put into string. And at this point, moving forward, if we were to analyze or output the value of, say, I, we'd observe an integer value of 10. If we were to do the same for D, we'd see 3.14 for string TEXT. Now let's just, I don't know, think about this a little more. So CN is going to use a formatted read. What if I simply try to read in a simple integer and the user provides 3.14? So what's going to happen is we'll begin reading. We'll see 3. Okay, that could comprise an integer number. And then we'll see period, which cannot be a part of an integer value. So at this point, I would evaluate to 3. And because we're not reading anything from this point, this is kind of just left over and still in the stream for the next time for us to come through and attempt to extract items. We would see this first because it hasn't flown by us yet. Okay, so let's take this up a notch. What if I want to read an integer character followed by another integer and there's no white space involved? So I'm expecting, or let's say the user inputs 3.14. Okay, when we're reading in this form, we get the integer value 3 like before. Okay, that can be put into I. However, point can't be, but 1 and 4 could be a part of, but point, the next one is a character. I got ahead of myself. So the next thing we're looking for is a character, single character. Point could be a single character. And then 1, 4 would constitute an integer. So at this point, I would evaluate to 3. C would evaluate to the period. And then J is going to evaluate to 14. So notice here, we're using formatted inputs, and there has to be a correspondence from what we're reading to where we're attempting to put that information. So this is the fun one I was, I think, looking forward to going through. I mean, the other one kind of shows the utility of this if you wanted to, parse out, say, the integer from the fractional portion of a floating point number, or maybe you're using a data set where you're storing the values as a comma separated and comma separated value notation. You could just read an int if it's all integer values, pull out the comma, kind of throw it away, read the next integer and put it into some sort of collection of data. Here, let's assume that we're reading and doing a formatted read in this way. We're expecting an integer followed by a double. And let's say the user inputs 3.14. We start reading 3. That can be a part of an integer. We look at the next one. Point cannot be. So I gets 3. Now a point can be a part of a floating point value, such as a double. So that's fair. 1, 4 can be. However, a line feed cannot. So 0.14 in this instance would go into D. Then we hit the line feed. It doesn't matter because, well, we're done reading. So I, at this point, would have 3. D would have 0.14 or 0.14 if you want to think about that leading 0. So reading from a file, and this is what I'm going to, I believe, conclude this lesson on. We're going to do this by, again, we're dealing with file streams, not the standard input-output streams. So we'll pound include fstream if we'd like to read from a file. Now, here's what's cool. Everything we've introduced you to about reading from CN is going to hold while reading from a file. So everything you just heard about, if you were to, say, use a file stream in place of the standard input stream, what we had would produce the same result, provided that the contents of the file were what we were showing you as user input. So we're dealing with files. So the input file stream, because we're reading from a file, is going to be the type of object that we're going to need to create. Here, I named my input file stream IFS, but you could name your input file stream something else. And then I bound that input file stream to file name.ext. Here's what I'm considering as the contents of that file. I'm just thinking the first example we did for reading from standard input, I'm just saying, okay, that's integer double text. You could put this with whatever and just make sure the format aligns and you could read from the file. But before we get ahead of ourselves, let's check to make sure the file actually opened. If it doesn't exist, you're probably not going to get past this stage. And again, we'll deal with the actual error handling when we talk about streams. So right now, if you're doing this in main, you could simply return 1 or maybe print something and then return 1 to communicate there was an issue. Once we get more into functions, if this, some sort of issue were happening within a named block of code, you could always throw an exception and then let the user determine what to do. We're not there yet though. So just, best thing to do here, terminate the program, because that's all we know how to do to handle this. So let's say we have, again, we're going to read an integer, double, and a string. So we're going to need locations to store that information that we're reading. Hence the declaration of I, the declaration of J, and the declaration of str. Now where we're reading from is CN. Where we're reading from is IFS, not CN. So notice here, IFS is the stream where the information is flowing from, as determined by the, this is the extraction operator, as communicated by the extraction operator. So we'll start and we can look. So we have 1, 0, white space. That can go into an integer. And again, this is white space delimited. So 1.0 is going to go into I. Next, we have 3.14, attempting to read that into a double. 3 is valid, point is valid, 1 is valid, 4 is valid. And then we hit the white space and we know we've completely read it in that portion of the input. So 3.14 is going to get put into J. Next, we have TEXT. This is being read into a string. T is valid, E is valid, X is valid, T is valid. Text will be put into str. And at this point, we've successfully read from our file an integer value, a double value, as well as a string value.